An interstellar object named Atlas is challenging humanity's understanding of the cosmos. The anomalous phenomena it exhibits have plunged astronomers worldwide into profound perplexity. We may be witnessing the most extraordinary astronomical event in human history. The physical laws governing this object appear to transcend our known framework. First, let's clarify Atlas's unique status in cosmology. It is the third confirmed interstellar visitor discovered by humanity. The first two were Oumuamua in 2017 and Comet Borisov in 2019. But Atlas is fundamentally different from them. Statistically speaking, its very existence is a miracle. Current models indicate the probability of such an object existing is less than 1%. This October, as Atlas approached Perilhana, the event took a startling turn. The world's most advanced observational instruments recorded inexplicable phenomena. The object exhibited acceleration impossible to explain with existing physical laws. Its trajectory calculations showed significant deviation. Breakthrough findings from the ALMA telescope network revealed Atlas's position deviated from predictions by 4 arcseconds. This figure represents a massive deviation by astronomical precision standards, equivalent to a bullet deviating 1 meter from its target after traveling 100 kilometers. This deviation points to a phenomenon called non-minus gravitational acceleration. Simply put, a force beyond solar gravity is influencing Atlas. Multiple solar observatories confirmed this discovery. STEREO satellites and the SOHO observatory both recorded these anomalies. Atlas's brightness variation pattern is unprecedented. More astonishingly, its reflected spectrum shows it becoming bluer than the Sun itself. This phenomenon contradicts fundamental optical principles. Reflected light from an object cannot appear bluer than its light source. This formally becomes Atlas's 9th major anomaly, the mass loss paradox. If Atlas adheres to the physical laws of conventional comets, the non-minus gravitational acceleration it exhibits requires massive mass loss to compensate. According to the latest calculations by Professor Abulob's team, to generate the observed acceleration magnitude, Atlas would need to lose at least 15% of its total mass. This figure is unprecedented in cometary physics. Assuming Atlas's mass is comparable to the largest known comets, a 15% mass loss equates to over 5 billion tons of material. What does 5 billion tons mean? It equals half the weight of the entire Greenland ice sheet, or 5 times the combined weight of all humans on Earth. According to the cosmic law of mass conservation, such immense mass cannot vanish into thin air. This evaporated ice and dust must form a debris cloud encircling the object. Theoretical models predict this cloud could span thousands of kilometers in diameter. Its reflectivity would be sufficient for detection by Earth's most advanced astronomical instruments. The decisive test. On December 19 this year, Atlas will make its closest approach to Earth, though still far beyond the Moon's distance. This proximity will allow detailed observation. If Atlas has indeed lost substantial mass, like a traditional comet, we absolutely cannot miss this debris cloud. Multiple world-leading observatories have formulated observation plans. The Hubble Space Telescope has scheduled continuous observation periods. The James Webb Space Telescope will conduct infrared band analysis. Chile's Very Large Telescope Array will also join the observation effort. Now consider the most exciting possibility. If none of the observation equipment detects the expected debris cloud, this would constitute Atlas's 10th major anomaly. An object accelerating without losing detectable mass directly challenges Newton's laws of motion. In classical mechanics, an object's acceleration must be caused by force. For comets, this force typically stems from material ejection. If no mass is lost, what force propels Atlas? This could point to a physical mechanism we haven't yet understood, or some previously unimagined method of propulsion, anomalies beyond comprehension. Compared to previously discovered interstellar visitors, Atlas is millions of times larger than Oumuamua, yet moves faster. This combination of size and velocity is extremely rare among known natural phenomena, according to celestial dynamics models. The probability of an object naturally achieving Atlas's size and speed is less than 1 in 1,000. Its orbital precision is equally astonishing. Its retrograde orbit makes an angle of less than 5 degrees with the solar system's ecliptic plane. Imagine someone shooting a basketball from the opposite end of the court with their back to the hoop, not only making the shot, but the ball passing precisely through the center of the net. The probability of this occurring naturally is a mere 0.2%. Even more astonishing is the coincidence of timing. As Atlas passes its perihelion, Mars, Venus, and Jupiter happen to align in specific positions, forming a remarkable spatial geometry, while Earth was positioned in a location, making direct observation impossible. The probability of this multiple coincidence is just 0.00005%. Atlas's behavior during its inner solar system transit was equally anomalous. Observations revealed it emitted material jets directed toward the Sun, completely contrary to all known cometary behavior. Traditional comets form tails pointing away from the Sun as they approach it, a fundamental principle of space physics. Yet Atlas displayed the extraordinary spectacle of jets blowing against the wind. In depth analysis of 9 anomalies. Anomaly 5 material composition. Atlas exhibits exceptionally high nickel content. Its nickel to a cyan ratio resembles stainless steel alloys produced on Earth. Naturally formed comets typically retain the primordial composition of their birth star systems. Such industrial alloy like proportions are unprecedented in natural celestial bodies. Anomaly 6. Extremely low water content. Traditional comets contain over 80% water ice by mass. Yet Atlas holds only 4% water ice. This challenges our fundamental definition of comets. Anomaly 7 concerns light polarization. Atlas exhibits an exceptionally strong negative polarization effect. This phenomenon has never been observed in other comets, suggesting its surface is coated with unique materials. Anomaly 8. The coincidental origin direction. Atlas's origin direction differs by only 9 degrees from the source of the famous 1977 wobble signal. Two renowned astronomical puzzles point to the same cosmic region. The probability of such coincidence is only 0.6%. Anomaly 9 optical properties. Atlas abnormally brightens near perihelion. Its reflected light appears bluer than the Sun itself. This violates fundamental optical principles. Scientific controversy. Faced with these anomalies, the scientific community has divided into opposing camps. Professor Avi Loeb's team argues that the simultaneous occurrence of 9 anomalies cannot be dismissed as mere coincidence. He invokes Occam's razor. The simplest explanation is often the most likely to be correct. However, if a simple explanation fails to account for all the facts, more complex possibilities must be considered. The mainstream astronomical community largely maintains a conservative stance. They insist that extraordinary phenomena require extraordinary evidence. All current observational data may still be explained by unknown natural phenomena. Perhaps Atlas originates from a unique stellar system. Perhaps it is a peculiar fragment produced by planetary collisions. What merits reflection is that both sides adhere to the scientific spirit. They both agree that more data is needed to validate hypotheses, especially the December near-Earth observations. This debate demonstrates science's capacity for self-correction. Future observations on scientific opportunities. December's observations will provide decisive data. The global astronomical community has established a joint observation network. Chile's ALNA will analyze material composition. Hawaii's Keck telescope will conduct visible light monitoring. Hubble and the James Webb Space Telescope will provide the clearest images from space. If a debris cloud surrounds Atlas, the Webb telescope's infrared capabilities will undoubtedly detect its thermal signature. If anomalous gas emissions exist, ALMA's millimeter-wave detection will immediately identify its chemical composition. If surface features exist, Hubble's high-resolution images will reveal these details. Einstein's general relativity offers another research tool: gravitational lensing. Our star's immense mass warps surrounding spacetime. As Atlas light traverses the sun's gravitational field, its path undergoes minute deflection. Measuring this deflection allows independent calculation of its true mass. Regardless of the outcome, humanity stands to gain. First possibility: Atlas is an unknown natural phenomenon. If confirmed as a novel comet, we would rewrite textbooks on comet formation and evolution. Its unusual composition might originate from entirely unfamiliar stellar systems. Studying it would be equivalent to obtaining exoplanetary material samples. Second possibility: an extraterrestrial technological artifact. If observational data supports this conclusion, human civilization would reach its greatest turning point. This would prove intelligent life is not alone in the cosmos and possesses interstellar travel technology. The third possibility is the most radical. Atlas may represent an existence beyond imagination. It might be neither a natural celestial body nor a technological artifact, but a material form governed by different physical laws, or a life form ubiquitous in the universe yet unrecognized. Regardless of which possibility becomes reality, Atlas has already fulfilled its historical mission. It compels humanity to re-examine our place in the cosmos. It reminds us that what we know may be but fragments of truth before the vastness of the cosmos. Humility and openness are the hallmarks of wisdom. The essence of science lies not in defending old theories, but in courageously following where the evidence leads, even if the path leads into the completely unknown. Invitation to participate. Now I need everyone's wisdom to contribute. The solution to this cosmic puzzle belongs not only to scientists, but to every person who gazes at the stars. Share your insights in the comments section. What do you believe Atlas truly is? Does our comet born of cosmic chance, a messenger from a distant civilization, or an entirely new phenomenon we haven't yet grasped? Which anomaly astonishes you most? The blue luminosity defying optical laws, the metallic composition resembling engineered alloys, or the uncanny alignment with the WOW signal source? For the December observations, what outcome are you most eager to see? The discovery of debris clouds confirming a natural origin, or the absence of findings pointing toward more radical possibilities? If you have friends fascinated by cosmic mysteries, please share this story. Science needs more attention and participation. Every new observer could bring fresh discoveries. Remember to subscribe to the channel and turn on notifications. We'll host a special live stream in December to interpret the latest observational data in real time, tracking Atlas's movements alongside astronomers worldwide. Whatever truth Atlas ultimately reveals, we stand at the very frontier of knowledge. This is the golden age of science. Every day holds the potential for world-changing discoveries, and you are participants in this era. Thank you for joining me in exploring this incredible cosmic mystery. Your thirst for knowledge and curiosity are the greatest driving forces propelling humanity forward. Now, share your thoughts. This universe awaits our collective interpretation.